In this video, we're going to talk about how to simplify square roots with variables. Now, we've done it in the past with just numbers, but now we're going to learn to do it with variables. And really, what we want to discover is, why is the square root of x to the 9th not x to the 3rd? Well, I can tell you right now, it does not say this. This 9 is an exponent, which acts very differently than a 9 that's a regular number. Let's find out why. When we simplified the square root of 50, we looked at a list of perfect squares and said, what number on this list is a factor of 50? We didn't choose factors like 5 and 10 because those aren't perfect squares, but 25 is, and the square root of 25 is 5. So the exact value of the square root of 50 is 5 root 2. How do we now do it with square roots? We're going to use this table to help us. We're going to do a little sorting activity, and it's really important that you look for patterns while we do this. What you want to do is you want to take the expressions that are in the far left column, and then you want to take these yellow cards and you want to match them in this column where they go. You should be writing these things down with your pencil. Take a moment right now and pause the video and see if you can match the yellow cards where they would go in this column. There's nothing really that can be simplified here. The square root of x squared is still the square root of x squared. X squared times x is x to the 3rd. This one here would be x to the 9th. If you took all these x's and wrote them out, you'd have 9 of them underneath the radical sign, so that's x to the 9th. X squared times x squared times x, that's x to the 5th. This is x to the 6th. This one here is x to the 8th. And this one here is x to the 7th. Now pause for a minute and think, is there a pattern going on here? I know that we skipped x to the 4th, the square root of x to the 4th. We did that on purpose because I wanted to make it all the way through the square root of 9 so that we could go back to our focus question and talk about why the square root of x to the 9th is not x to the 3rd. You can talk about this pattern in whatever way you like. It says, what is the pattern for simplifying even versus odd exponents underneath a radical? You should already start to see a pattern going on here. Now, what about the blues? How do these blue cards get arranged into this column? Well, first of all, this one here, that has to go there. This really can't be simplified any further or written in a different way. But if I look at x to the 4th times x to the 4th, that's a different way to write x to the 8th. And x to the 3rd times x to the 3rd, that is a different way to write x to the 6th. X squared times x, there really is no other way to write x to the 3rd underneath the radical. X to the 7th could be written as x to the 6th times x. X to the 8th times x underneath the radical is a different way to write x to the 9th. And x to the 4th times x under the radical is a different way to write x to the 5th. Again, take a minute and look for a pattern. As you go from an even exponent to an odd exponent, this is another odd exponent. Even exponent, odd exponent, even exponent, odd exponent. How are these blue cards related to the yellow and to the original expression? We'll do the pink cards in the next video.